So now we're going to start a short series of 3 talks dealing with measures of disease frequency, which you might think of as counting. One way of thinking about it is counting the number of cases of disease, although it's a little more complicated than that. So we're going to start today by talking about measures of prevalence, and in the next talk we're going to deal with measures of incidence, and then in the final talk we're going to introduce a few other measures of disease frequency. So generally, when we want to measure disease frequency, we need to make some decision about 3 things. These are the population that we want to study, the health outcomes we want to investigate, and also the time frame in which these measures take place in. So let's start with population. So population is a defined group of people within a defined boundary. So that boundary can be a geographic area, it can be some sort of organization, and it may be within a particular time frame. So just we need to place some boundaries on the population, and we can limit it to people of one race or ethnic group, or one sex or another, or a particular age group. There are really an infinite number of populations, and these are just some randomly made up populations, but there's no limit to the number of populations that we can conceive of. A slightly specialized type of population is what we sometimes refer to as a catchment population. So this is a population where it's difficult to kind of draw a geographic boundary around them, but they might be defined by their attendance, say in a particular healthcare facility, or it could be a particular school, for example, or anyway, people who attend a certain facility. Usually refers to hospitals or healthcare facilities. So the boundary is not clear. That may be interwoven with a catchment population for other facilities. So we often would, for example, use patient lists to identify the catchment population of a particular hospital. And we can also think of populations divided into 2 broad types. Fixed, sometimes referred to as closed populations, and this is where membership is basically permanent and defined by some sort of event. And those are 2 examples there. And we can also think of dynamic, also referred to as open populations, where the membership is constantly changing as people come and go. Now, I should mention here that the terms fixed and closed population are used in slightly different contexts by some epidemiologists, but I think the distinctions are not important, and I think it's most people refer to them fixed or closed in a synonymous way, and the same could be said to apply to dynamic and open populations. Certainly during this course I will use the terms interchangeably. You can think of them as dynamic and open is exactly the same. So an important characteristic of these 2 different types of populations is that the closed population, because it's defined at one point in time, right at the beginning, and then over time people will die, and eventually they'll all be dead. So a closed population tends towards 0, whereas a dynamic population can fluctuate in all sorts of ways, could fluctuate in a more dramatic way than this, but it doesn't necessarily trend towards 0. So that's population. Now we need to make a decision on the health outcome that we're interested in. So here we often use a disease case definition. So this is a standard set of criteria, just to make sure that the cases in our study are consistently classified, and there's not. We try and minimize disease classification as far as possible. We're going to be talking about misclassification in a future lecture. So case definition can include symptoms, signs, lab tests, and so on. And it may change over the course of an investigation, and this is particularly so with acute disease outbreaks, where you start off knowing very little, and you might define a case for the purpose of the investigation, sort of very broadly, say with vomiting and diarrhea. But as time goes on and you learn more about the disease organism, you might bring in a requirement that there be a lab test, that there be lab confirmed. So the case definition can change depending on the stage of an investigation. And here's, just by way of a example, here's an early case definition for AIDS. And it has changed a lot over the course of time. But if I were to try and show you the current case definition for AIDS, it would not fit on this page. So this one has the convenience of being relatively brief, and so you can see that there are a combination of signs and symptoms, and this was used in around about 1986. So generally speaking, disease frequency measures, which I'm talking about to date as prevalence, they quantify disease occurrence in a population, and when we talk about the source population, we sometimes refer to that as the denominator population. And then we talk about the number of cases of disease, we sometimes refer to this as the numerator or numerator population. So, and we use those in the sense that you're familiar with as a fraction, the numerator and the denominator. And then, of course, we need to know the time frame in which we're interested in. So there are several parameters used for measuring disease occurrence, and the first one of these is a proportion, which is basically a fraction. And here I've example number of males divided by the total number of people in the population. The second measure which we use is we call it a rate. And when we talk about a rate, strictly speaking, time should form part of the denominator. And when I get to talking about disease incidence, what I mean by this, time as part of the denominator, will become much clearer. So, prevalence. Let's talk about prevalence. So prevalence is a proportion, and it refers to the existing cases of disease in a defined population. Existing cases in a defined population. So it's just a proportion of people who have a particular health condition at the time. And so we can further break prevalence down into two types. And so there's point prevalence. So this is prevalence at a specific particular point in time. And most measures of prevalence are actually point prevalence. The other one is period prevalence, and this, less commonly used, but sometimes useful. It's the proportion of people who had the disease that we're interested in at any time during a specified calendar period. So let's talk about how they're calculated, and we'll come back to the distinction between point and period prevalence, how to distinguish between them. So first of all, point prevalence is conceptually fairly straightforward. It's the number of existing cases divided by the number in the total population at a point in time. And so by this example, we have an example there of asthma. 7,000 people with asthma in a population of 70,000 on a particular day, and that gives a prevalence of 10%, which is not unrealistic for asthma in some populations. So period prevalence refers to the number of cases at any time during a defined time period over the total population during that time period. So you may, for the sake of the total population during that time period, take the midpoint population, or you might take the average of the population at the beginning or the end of the time period. And period prevalence includes cases that were existing at the very beginning of that time period, and cases that were newly diagnosed between the beginning and the end of that time period, which you always have to define. So here's an example, with an example involving hepatitis B. So it includes the number of cases present on January the 1st, plus the new cases, which we will refer to as incident cases, and we'll talk about what I mean by incidents for incident cases in the next talk. So we just basically add the 29 existing cases to the 13 new cases, divide by the, in this case, the mid-year population of 1600, and we get a period prevalence of 2.6%. So people get very confused about point and period prevalences, because quite often a point prevalence will look like a period prevalence, but it's not really. And this is because, although we talk about getting point prevalence at a point in time, in fact, the collecting of those data for point prevalence, which may involve a survey, maybe going house to house, for example, doesn't all occur simultaneously, doesn't all necessarily occur in one day. It may take place over a period of weeks, or it could take place over a period of months. So the point is here that there is like one contact with a person, and it's the question of whether or not they had the disease at that point of contact. So to illustrate this, here's an example, in referring to cold and flu. So we might, if we were to say, ask each person once, do you have a cold or flu now? And then we compiled those statistics, then that would give us a measure of point prevalence. But period prevalence would be obtained if we asked each person, did you have a cold or flu at any time during, say, the last 12 months? And so then period prevalence would have to be expressed in relation to that time period. So where people get confused is it's often the case we talk about the data were collected between, over a 3-month period, but the nature of the inquiry at the time was one contact with each person, and we asked about that point in time, and then so it is a point prevalence, not a period prevalence. So try and remember how to distinguish between them. So prevalence, when do we use it? So it's usually regarded as the most useful when you've got health conditions, diseases, which come on slowly, and then people eventually become aware that they have this condition, and particularly conditions that persist, and certainly if they're not rapidly fatal. So prevalence is particularly useful in those circumstances, and so 3 examples of that would be asthma, arthritis, and diabetes. But the thing about prevalence, it's very influenced by the duration of the disease. So people with long duration disease, for whatever reason, because they had a non-fatal case, or they weren't treated, for example, people with a long duration form of disease are more likely to be caught up in a prevalence survey, reported in a prevalence survey. And it's also introduced by the rate of removal of people with the condition. So people may die of it, or they may be cured, or they may, for some reason, migrate out of the area, in which case they're not going to be counted in the prevalence statistics. But the major limitation really is that it doesn't provide any information on the rate at which new cases occur. And as you'll see, when we're examining particularly the benefits, if any, of interventions, then we really need to be able to measure the rate of occurrence of cases to see whether it's trending upwards or downwards or just sort of flat, whatever it may be. So that's why prevalence has this limitation relative to incidence, which we're going to talk about next. sometimes people will say that prevalence quantifies the burden of disease. So if you hear talk of the burden of disease, usually that's a reference to prevalence of a disease. So just to summarize, prevalence of a disease is very affected by a number of things. So it's increased by this list of things here: long duration, in-migration of people with the disease or susceptible, and so on. And it's decreased by a kind of the reverse set of conditions, really. Shorter duration cases, and so on. People who are cured, or improved cure rates. So that can affect disease prevalence. This is regarded as a limitation of prevalence as a measure of disease occurrence.